Good afternoon. That was a tough one to follow. Llama 3 is an amazing model, and I'm proud to say that it's available on Azure AI, but that's not what I'm going to be talking about today. I'm going to be talking about how you'd build large-scale training jobs and how do you operationalize your workloads using large language models on Azure AI. So, with this disruption and the evolution of generative AI, there have been massive amounts of innovation at a massive, at a velocity that all of us find it hard to keep up with. Llama 2 was released back in July. I remember that I was thick in the middle of, working with Meta to onboard that to Azure AI. I don't do that right now. I moved on to something else, but like my colleagues worked on it. And imagine that when Meta introduces Llama 3, we are working to bring it to our users at the, almost instantly. And then you as developers and who are working on the, in the space, you have to now adapt to it, right? That's happening internally at Microsoft as well. All the Copilots that we have built have had to keep up with all of this innovation that we need to bring to life for all of our developers. And all of this is done in our Azure AI infrastructure. So what is Azure AI? So it's essentially a collection of services and infrastructure that is used to go build large-scale AI solutions. We have the Azure AI services, the AI search. There is the Azure machine learning platform for you to build and operationalize large language models. Azure AI Studio is targeted around Gen AI developers who want to build applications around an LLM. And all of this is sitting on top of our planet-scale AI infrastructure. So what I'm going to be talking about today is how do you coexist in this world of constant innovation and how you would want to think about LLMOps in the real world. I mean, all of you perhaps go through the 3 stages and maybe even more of how you begin with ideas where you want to try your business solution on a model. You want to do some high-level, low-touch evaluation to see if your scenario can be met with the LLM solution that you are working with. This is essentially trying to build your prove your hypothesis. So after that, you might want to go in and build more context into your prompts and even try and change the model itself to kind of make it more domain specific. And then finally, you want to take that solution and then you want to operationalize it, deploy it in production, set up scales to vary with the traffic that you would have. And surrounding all of that, you would need a management platform so that you can do version control, for example, traceability, drifts, things that you would need to run a production workload. So in Azure AI, we offer you a single place to build your platform from soup to nuts, from ideation all the way to operationalization. And we have worked very hard to embrace the Gen AI evolution. So when we think about customization of the model, there are many layers to it. Top to bottom in this diagram, we're trying to show where one may start, but then where you may go end up. And there are different layers of complexity and cost associated with undertaking any of these. At the highest layer, enabling some solution with prompt engineering and tuning your prompt may be a great place to start because it can be easy to get started, it can be simple, and it can help you validate your solution. The next layer from that would be things where you want to bring your own data, where you want to augment the prompt with indices which are used with the local context of your prompt, of your situation. And this is what popularly is called RAG. And then you may want to graduate from that into actually fine-tuning. Even within fine-tuning, one may do a fine-tuning solution based on APIs, where you submit a job and access the fine-tuning endpoint via a simple API interface where it's a managed service. Or you may do further more deeper fine-tuning with some level of customization or tuning hyperparameters or changing even the kind of task that you want to fine-tune. And then finally, you may want to do a full-scale custom model development, which is another example of deep data science work with operating on massive amounts of data. This kind of workload is potentially task agnostic, but it has different kind of complications. At the same time, it can give you much better performance for your scenario. But if we want to split this, and let's look at the first half of this journey, where you are not necessarily changing the model structure itself. You are working mostly around engineering your prompt and identifying how a given model itself can be used to fulfill your solution. So for that, let's talk about prompt engineering first. And here we have an amazing demo and solution builder, Seth. He has built a demo, and in the interest of time, I'm going to just play that instead of doing a live demo here. So thanks in advance, Seth, if you're listening anywhere. But let's see if this is going to work and the audio goes through.
Prompt flow enables you to build flows that take information from top down to create a prompt that is then sent to the LLM. In this case, we're doing two things. We're going to look up the customer by ID, and we're also going to look up information pertinent to the question. In this case, we've used a vector embedding to retrieve some documentation from Azure Cognitive Search, and here we've literally looked up a customer from Cosmos DB. Notice that the code that is written is simple code that anyone or any developer could write. No need for advanced degrees or understanding of complex machine learning concepts. Once all of this data has been assembled, you can literally create the specific text that goes into the LLM. In this case, notice that it's injecting the name of previous purchases directly into the prompt. This is then sent into the LLM, and the response comes out like so. Notice that it knows about Emily as well as the previous purchases that she's had. Let's talk about safety for a second. Because I'm using Azure OpenAI, notice that the content filtering is built in by default. If I go to the GPT-3.5 Turbo deployment, you can see that this deployment has the default content filter. But for other situations, you may want to create customized filters. For example, if you're creating a game, there may be a little bit more violence, so we can set that to medium, hit save, and now we can use this customized filter in our deployments as part of calling the LLM. No need to do anything else in the application. Now this particular deployment will work that way. I don't want to do that, so I'll leave that there. The next question is, can we use other models? Of course you can. Here's the model catalog inside of Azure ML, and notice that there is a lot of models, but I've specifically pointed out the Llama 2 models from Meta AI. These are easy to deploy and use. All you have to do is look at the model card and then deploy, and then you can use these as well inside of PromptFlow. So how do you know this is actually working? Well, it turns out that you can either run it directly in here like I showed you, or you can run bulk tests to make sure that it answers questions well. I've already done this. Let me select this bulk test that I run, and I basically created a data set with a bunch of questions so I can see how the entire prompt flow will respond. Notice that I'm asking questions that I'm pretty sure are going to be asked, and notice that I have the answer as well as the context or information. But what if we want to do more? What if we want to measure how grounded the answer is in the context? To do that, you can create evaluation runs such as groundedness. And what this does is this measures how well grounded the answer is in the context. And notice we have a score between 1 and 5. So the question is, how did they score this? Well, it turns out that evaluations are also prompt flows. So notice that we're using GPT-4 to figure out how grounded the answer is in the actual context. And what's cool about this is you can also create your own custom evaluation flows so you can measure anything that's important to your particular business. Notice that I've showed you a couple steps in the development lifecycle of LLMs. The first was building the flow itself. The second was testing the flow using evaluation flows. All right, let's talk about deployment and monitoring. Deploying these things is really a single-click operation. Let me show you the deployment that I've already done over here. Notice that this is deployment, it has traffic allocation, and you can test the deployment directly inside of this particular application. This is a deployed API endpoint that now any developer can use. And notice that the answer is reliable and consistent. We also helpfully provide some code so you can put this into your own application, but you can also monitor the calls that have been made, the latency, as well as a number of other things down to the very logs of the actual execution. Finally, you might think, well, developers want a more localized experience of how this all works, and maybe they don't want to use a portal. That's great. It turns out that we have a Visual Studio Code-enabled experience that allows developers to do the same thing they do online, but the difference being that now when they're writing code to do customer lookups, it's literally code that they can check in and use. And the best part about all of this is that this extension allows you to look at batch runs just like you did online, and you can see every single thing that came out down to the milliseconds of how long it took to run this. In summary, Azure Machine Learning's prompt flow is an end-to-end development experience that lets you create LLM-inspired applications to create delightful new contextual experiences for users.
You got all that? That was a lot to unpack. But the best way we could do this is to play a video, but all of this information is available online and public. So, you can definitely look at this deeper. So prompt flow is essentially our offering for a solution where you can create your AI workflows around an LLM. You can essentially iterate through flows. You can prototype. You can essentially evaluate. You can use pre-built templates that we have, as well as you can go through and do all kinds of version controlling with CI/CD pipelines. So this is our one-place shop available in Azure AI Studio and Azure Machine Learning for you to go build your own prompt-based solutions around LLMs. And as Seth talked about, you could be using the Azure OpenAI models, the OpenAI models that are available through Azure OpenAI, but also the suite of models that are available through our model catalog. There are many open source models there, including state-of-the-art models like Llama 2 and Llama 3 that we announced this morning. So prompt flow is while we showed you a UI-based interface and Seth towards the end talked about the Visual Studio Code interface, there is the SDK and CLI interface is also available, so you can have a code-first experience to engineer your prompts. Next, let's talk about RAG. So at a high level, the idea with RAG is that in addition to tuning your prompt, you may want to provide additional context, local context that's related to your solution. So in terms of building a RAG solution, you would have to first actually create an indexer. So you'd need to feed your local data, whatever custom information that you have, into your and build a knowledge database. This would be your vector index. This vector index is then actually used to augment your prompt before calling the LLM. This essentially enables you to create a much richer prompt and therefore thereby get much better results from the LLM, because the LLM now has more information to work with, which is completely local to your knowledge, your scenario. This is what's provided back to the to the orchestrator, which then sends that query along with your prompt to the LLM, which is then the LLM then processes and responds with a much more localized, precise answer. This in turn then becomes your answer, which is what you may use to process in your solution. So RAG is also available as a scenario within our Azure AI Studio, and you could then use all of these tools to feed local context into your prompt-based solutions. Next, let's talk about what are the next layers of customization that you'd have. We talked about at a high level fine-tuning. So we have many models that we offer in our model catalog in Azure ML as well as Azure AI Studio. We always will aspire to be up to date with whatever is out there in the industry, because it's our goal that you as the user get access to the state-of-the-art models. So this, of course, the Azure OpenAI suite of models are related to what OpenAI releases for us, and we have an enterprise-grade offering with the Azure OpenAI service, which is GA. Meta is a model creator, very much like Mistral and others, and we would work towards bringing in the latest and greatest models from Meta here. This slide should have been updated with Llama 3, but I think there was an embargo, so I could not include Llama 3 on this list. In addition to the large language models that come out from the ecosystem, including Hugging Face, Microsoft also has a family of small language models. The models around the 5 family. These are models that are specifically targeted at smaller and more directed applications and have a much smaller footprint compared to the large language models that are out there. And these SLMs are gaining popularity, and they are also options as it relates in terms of LLMs for your applications and for you to use. I'll just quickly walk through how you could be using one of the LLMs from our model catalog. So here I'm showing that you pick Llama 2, and this is the model card which shows actually all the information related to the model. Here there are multiple fine-tuning tasks you can fine-tune the model with. We will pick text generation, And when you click on text generation, you can see all of the information and details around what the cost per token, et cetera, and all the agreements that you would have to accept before you start fine-tuning. And then you can continue to do a fine-tuning job. This is an example of a fully managed fine-tuning service where you get exposed to basic information that you'll need to feed, like your training data and your evaluation data. But here, like, you provide basic, you would upload data files that is related to the job that you want to do. The task we talked about here is text generation. You would upload your data files. Here, what we are showing is something that has already been uploaded. Then you actually define what's your prompt and what's the ground truth, because this is essentially what's going to be used by the fine-tuning job to evaluate or train the model. As with any fine-tuning job, you would also need to update or add validation data so that the model can actually look at the learning rate and other parameters that you would use for fine-tuning. We expose limited set of parameters here for you to fine-tune the model. And then once you have set your parameters, you can submit the job. And it's as simple as that for you to start fine-tuning. So what we will do here is we will not show a fine-tuning job because it takes time, but you can imagine, like, once you fine-tune, the model will show up in your model registry within the AI Studio. And then from that model registry, you can look at all of the details around when the model was trained and what version it was, but you can also go ahead and deploy. And this slide shows the different types of model metrics that we would expose as a part of the fine-tuning job. This was a very quick demo on how you could be running through a fine-tuning job based on a UI approach that we have for our Azure AI Studio. Next, as we move to the next layer of training, it would be about building a custom model. Here, Azure AI again offers a fully managed platform for you to build and operationalize your data science workflows to customize the model. We are an open platform in the sense that you could be using PyTorch or TensorFlow or any other framework like Onyx to run your training jobs. So there are many layers of customization you can use, and we offer the latest state-of-the-art infrastructure for you to run the training job. We have the latest NVIDIA GPUs, and we have also announced the AMD GPUs that are going to be introduced in our fleet. And therefore, as a user, you have flexibility to use any hardware that is going to be available at scale on our platform. So at a high level, like the deep learning stack that we have is the same that is used internally to build all of the custom solutions that we have, where we build models from scratch, like Phi 2 and the Phi family, or where we actually adapt existing models to go build our Copilot solution. So the machine learning stack that we have has the state-of-the-art hardware, which includes InfiniBand connected multi-node infrastructure for GPUs that can scale to thousands of GPUs on hundreds of nodes. We enable you to scale up and down depending on the size of your workload. We have our own Azure container for PyTorch, which is the default PyTorch training environment that we enable in Azure. And then finally, Azure Machine Learning is the platform on which you can run and manage your workloads, track metrics, review jobs, debug your experiments, so that you can fully customize your training scripts to build the right model for yourself. So again, in the interest of time, I'm going to speed run a quick demo on a custom training job, but to show you at a high level the different pieces that we have. So what this is showing is basically a notebook where we are running a distributed PyTorch training job on a sample data set. At first, you would set up your Azure environment, which requires you to go ahead and authenticate. If you all are not familiar with Azure, this might seem complicated, but it's not. It's essentially connecting your VS Code session with your own Azure services. So then once you set up your environment, you essentially have to set up your compute infrastructure. Here what we are doing is you'd have to pick from different instance types that Azure offers. We looked at an NC series GPU machine here to run our job. But this essentially gives you the idea that like once you set up your compute, you now have your compute infrastructure to run your job. Next, you would do your data preprocessing. In data preprocessing, you might actually be loading data from a data store, or you might be downloading the reference data sets from online. This is essentially the preprocessing step you would need to prepare the data before you run a training job. And this data preprocessing typically would run on a CPU, with any kind of customization that you may want to do, and all of that code is, of course, available to you in samples. So next, once you submit the training job, let's switch over to the Azure Machine Learning Studio, where we provide a nice UI-based interface for you to monitor your training job and review all the things that are going on in your experiment. There are rich interfaces for you to review the training metrics, track your experiments. We also provide much deeper platform level data for you to understand whether you are whether you're optimizing your infrastructure based on like the training libraries that you use. And then finally, you have a, this is showing actually a custom training script where the train.py is set up in as a sample here, like using the basically torch.nn module as the base framework for you to run a model training job. And this kind of, this becomes your code-based experiment for you to run a fully custom training loop through with the right kind of training metrics that you would have in terms of checking validation loss or accuracy and anything else that you would want. If you're looking to build your own Copilot, or either by using prompt engineering or RAG or fine-tuning or custom training, start in Azure Copilot. Start building your Azure Copilots in ai.azure.com. That would be a good starting point for you to look at very many ways and different directions that you would like to go. And then finally, a shout out to our Founders Hub team. We have a booth in the main floor. You should check out all the benefits that we offer for startups as we look for you to build on Azure. There is initial credits available. You can use that to use against all of the different Azure AI services that we have. You can accelerate your time to value by starting with pre-built solutions, prototyping quickly, and then transitioning to operationalizing them at scale. So with that, thank you very much.